Hello and welcome to the 7th video for Outcome 30.6, all on counting principles. In this lesson, we are going to look at a combination of the fundamental counting principle, permutations, and combinations. So on our rubric, we are going to be looking at solving permutations, ones with conditions and one with repetition. We'll look at solving combinations, especially when there's more than one set. And we're going to look at some fundamental counting principle questions as well. So again, our goal is to just solve some problems that use permutations and combinations. Remember that permutations mean order matters, and combinations mean that the order does not matter. So we're going to look at all different types of questions, kind of as a review of what we've already done. So here's the first question. It says there's 5 swimmers in the first heat of a race: Abby, Bree, Kelly, Dina, and Emily. A says, how many ways can they finish first, second, third? And then B says, how many ways can they qualify for the top 3 spots? Well, if we are trying to win first, second, or third, that means that order matters, right? If I get first, that is different than getting second, and that is different than getting third. That needs to be a permutation question, again, because the order matters. So that means that I have 5 people to pick from. I need to pick 3, 5P3, and when you punch that in, you get 60. Now B just says that we want to qualify. So in order to qualify for the next race, I just have to be in the top 3. It doesn't matter if I'm first, second, or third, just got to be the top 3. So in that question, order doesn't matter. When order doesn't matter, then I'm using a combination. So 5, choose 3, which means that there's less options, right? Combinations always have less, and I have 10 different combinations of people that could qualify. So in every question, you need to consider whether order matters or order does not matter. That is the most important thing. Once you figure it out, if order matters, you're going to use a permutation, or you could use the fundamental counting principle, the one with the blanks. If order does not matter, then you're going to use combinations. So here's the first main example today. We have a piano teacher and her students. There are 3 boys and 5 girls, and the photographer wants all the boys together and all the girls together. How many ways can the teacher and the students sit in a row of 9 chairs? All right. So I'm going to start with just the students. There's 8 students. 3, 4, 5, 6, 7, 8. And I want all the boys together and all the girls together. So there's really 2 ways that I can do that. I can go boy, 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 and then girl, 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 girl. Or I could have the girls first, and then the boys second. Whenever I'm looking at ordering people, I generally use the fundamental counting principle. So I know that there's 3 boys, so 3 options for the first boy, then 2, then 1. I know that there are 5 girls, so 5, then 4, then 3, then 2, and then 1. Same thing on the bottom. I have 5 options for this first girl, and then 4, and then 3, and then 2, and then 1. And then I have 3 boys, and then 2 left to choose from, and then 1. So now I've dealt with the students. Now, it also says there's a teacher. So if I want the girls together and the boys together, where can the teacher go? Well, the teacher could sit on this side, and then the boys would still be together and the girls would still be together. Or the teacher could sit on this side, and the boys and girls would still be together. Or the teacher could sit right there, and the boys and the girls would still be together. The teacher has 3 different places to stand, so I'm going to multiply that answer by 3. It is the same thing down here. The teacher could go in the front, could go in the back, or could go right in the middle of them. I'm going to times that answer by 3. So now if I go to my calculator, I punch in 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1 times 3, I get 2,160. Same thing on the bottom. When I punch that in, I also get 2,160. And again, because it's an OR question, whenever you have options, I need to add. So I end up with 4,320 different ways I can arrange those students in a line. So there's an example of using the fundamental counting principle. All right. The next example basically says that I'm trying to make five card hands that contain at the most 1 black card can be dealt. So at the most 1 black card means at the most I have 1 black card, or I could have no black cards. If I have 1 black card and I'm making 5 cards, it means that there must be 4 red. And if I have no black cards, it means there must be 5 red. So this one's 2 options, right? It's either 1 black, 4 red, or it's no black and 5 red. So let's punch in our options. So there are 26 black cards. So out of the 26 black cards, I need to choose 1. And out of the 26 red cards, I need to choose 4. So 26 choose 1 is 26. 26 choose 4 is 14,950. And if I multiply those two things together, I get 388,700. 388,700. Now in the next option, there's no black, so I don't have to worry about it. Just 5 red, so 26 choose 5. And 26 choose 5 is 65,780. So now I take those two answers, and I simply add them up, because it's an OR question. It's one or the other that needs to happen. So that is 454,480. So that is a question of combinations, because order doesn't matter when I'm being dealt cards. I'm going to use a combination. Let's try the next example. In how many ways can all the letters in the word flowers be arranged if there's no restriction? So I'm arranging letters. Arranging letters means that order matters, which means I'm going to be using a permutation. Now the first thing I look for is repetition. In the word flowers, there's no letter that's repeated. So there's 1, 2, 3, 4, 5, 6, 7 letters. If there's no restrictions, I have 7 letters. I want to pick 7 of them. How many ways can I arrange that? Well, 5,040 ways. B then says, how many forward letter arrangements? Well, again, order matters because it's an arrangement. So I have 7 letters to pick from. I want to pick 4. 7P4 is 840. So these questions were permutations because I'm arranging things, and that means that order matters. It's got to be a permutation. Last example. How many arrangements can be made using the letters in the word books? So again, I'm arranging, so I know it's going to be a permutation, right? But as soon as I see I have 2 O's, there is repetition. When there's repetition, I have to use that formula n factorial over the things that repeat, whatever they are. So in this option, I have 5 letters, B, O, O, K, and S. Out of those 5 letters, there's only 2 that repeat. There are 2 O's. So 5 factorial divided by 6 factorial is 6,000. There are 6,000 different ways. So that concludes lesson 7. It's now time to try practice 7.